I was only. She's not even here. She's not gonna like.
Get your facts straight.
Section 3.4, we're talking about polynomial equations, polynomial functions. We're going to look at the graph of ax to the n power. We're going to graph general polynomial functions, talk about what happens at 0. We're going to look at turning points, different graphing techniques, which we've talked about graphing techniques quite a bit already. Translation, stretches, compressions, reflections, that kind of thing. A new concept up there is the intermediate value theorem. We will not get to that today. We will use the calculator to approximate real zeros and polynomial models. Again, when you see the word models in math, that means it's the word problems involving polynomial functions.
If we're not going to get to 6 today, are we going to get to 7?
Negative, sir.
Okay.
What? There's no 6, it's 3, 4.
Yeah.
Oh. I think we got
You
a
should
smart
keep
class.
I am so glad y'all share your brilliance with the recordings.
Are you a register? Do you work at the register?
Me? Yeah. How
I'm
many?
sorry.
Okay,
What?
here's what I want y'all to do. I want you to not overthink things. I want you to almost put on your elementary mind. Okay? When I ask a question, some of you have it on all the time, but when I ask a question, don't worry about the vocabulary you're using. Just answer it as honest and what you see as possible. Okay? In front of you, you see 3 graphs. You see f of x equals x, f of x equals x cubed, and f of x equals x to the 5th. How are they alike?
They're all
They have an
blue.
X.
They're all blue, they're all going up,
No,
they're all odd,
They're all x to a power.
they're all x to a power.
They're both.
They're both going to infinity.
Okay, they're both going to infinity on both sides.
Is there more?
On both sides they're going to infinity.
Yeah.
Negative.
So on the left side they're going to,
Negative.
they're going down, and on the right side it's going up. Do y'all remember talking about in behavior last semester?
Mhm.
The whole up, down, down, up, down, up kind of stuff?
Not
Okay.
really.
I remember you saying stuff, but
Is there more?
Anything else that they all have in common?
They go through the 0, 0.
All 3 of them go through the origin. Good.
Oh, they're all parent functions.
They are all parent functions, yes. 2 of them we're very familiar with, 1 of them we're not. But it kind of looks something similar. Okay? That wasn't a hard question. Okay, great job. How are they different?
The
One
power.
is straight.
That one on the right has those little red boxes.
The power. Okay, the one on the right has little red boxes.
What?
Do what?
The amount of zeros.
The number of zeros is going to be different. Now you're kind of talking ahead. Okay, you're talking about high school mind here. Okay, your elementary mind has no idea what a 0 is.
It's
Okay.
it's curved.
Do what?
It starts to curve.
Okay, that's a similarity, but what's a difference there? In that same section, what's the difference there?
One is wider. One
Huh?
is a very box.
Curve is longer than
The curve is longer. Okay, good. How else are they different?
Some are steeper than others.
The steepness, right? As that exponent gets bigger, what's happening to the steepness? It's getting steeper. And what happens at the origin? As that power gets bigger and bigger and bigger, as that exponent gets bigger and bigger and bigger, what is happening at the origin?
It doesn't move.
Stays constant longer.
hey,
It
that's
looks
too
like it
smart.
might be constant, but it's never constant, okay? Does it appear to get flatter
Yes.
for a longer period of time? Yes. Okay? Here's a similarity that y'all didn't mention. Y'all did mention they all go through the origin. They also all go through the point 1, 1. They also all go through the point -1, -1, don't they?
Oh, yeah.
All 3 of them do. Because what is 1 raised to any power going to be?
One.
1. what is -1 raised to an odd power going to be?
4.
-1, right? So those 3 points are on all 3 of those graphs, okay? Okay, one of the first things that y'all said when I asked about what they have in common, someone said they're always going up. That is a very true statement. Okay, what's a tangent line?
Good question.
You talked about tangents in geometry.
I've heard this.
What's a
word.
tangent line?
I forgot.
Okay,
I'm not
Should
sure.
we just
I'm bringing it over here to get closer to the camera. You see this curve right here?
Yes.
This is a curve. Okay, this is a straight line. If I was to take this straight line and have it touch the curve, how many times does a straight line touch the curve? 1 time. I don't care where I put it, this straight line only touches the curved area 1 time. That's what a tangent line is. Okay? Now, for the first graph up here, I'm not going to talk about a tangent line because it's straight. There's no curve to this thing. But this graph is always going up. I know that it's going up because the slope of this line is positive. Okay? This line is always curved. Okay? Which means because this graph is always curved, I can take a tangent line to it. And as that x increases, what is happening to my tangent line?
Curves.
It grows less steep.
Okay, right, it's less steep, but is it still positive?
Yeah.
Okay, so this tangent line is positive. It's positive, but it's getting less steep and less steep and less steep. And you know what? It'll never get flat.
What?
But right before it almost does, it starts getting steep again. When was the slope of this line 0, or when was it negative?
No.
Never. The slope of this line, no matter where I put it, is positive.
Oh.
Okay? Which shows that this graph, yes, it is always increasing. It's hard to tell. And as the exponent gets higher, it gets even harder to tell. But this line too is always increasing. It's never flat. And the only way to see that would be to zoom in. So if you actually went into Desmos maybe and typed this in and zoomed in and zoomed in and zoomed in and zoomed in, you would see that it would look more like this. As you zoom, that makes sense?
Mhm.
As you get close, okay. So that's what's going on here. Good job on your elementary brains. 3 more graphs. We're now talking about n being even. Back to elementary mindset. What do these graphs have in common?
They go up infinity.
They're curves, what?
They go up infinity.
They cross the
Okay, on both
point.
sides they're going up to infinity.
They cross the point 1, 1.
They all include the point 1, 1.
Not -1, 1.
They all include the point -1, 1.
Oh,
And
They
negative
cross
1,
the
1.
origin.
They all include the origin.
I thought you were talking about -1.
They all have a parabolic look.
1 is wider than the others.
I'm talking about the similarities.
Oh,
Similar to say they all have even exponents.
They all have even exponents. Okay. The last one, y'all told me that they're all always increasing.
Yeah.
What are these doing?
Increasing on the right.
Okay. So you're saying from 0, they're increasing. Okay. And what's happening on the other side?
decreasing.
From way over here to negative infinity, it's coming down, so they're decreasing. Right? They all have that in common, don't they? Okay. Good? Differences.
Orange boxes.
Okay, someone likes the red boxes again.
So,
It's just right there.
Curves are different, so I think.
The curves are different.
Different, they're on all the, well, some are steeper than others.
The exponents are different.
Okay, as the exponent increases, the steepness increases, except for that area between -1 and +1. What's going on there?
It's like,
Between -1 and +1, what's happening? Is it getting steeper down there?
yes.
ow.
Looks like it flattens out as it gets closer and closer and closer to the origin to me,
Mm-hmm.
right?
I think the last one.
Okay. And if okay, great job. And if I was to go back and talk about my tangent line, over here, as I get closer and closer to 0, I do have a negative line, which means this graph is in fact decreasing. Continues to decrease, continues to decrease. Does it ever hit 0? It better, because that's the only way it can go from negative to positive. It can't just automatically jump over 0. Okay? Where the slope is 0, these points here are pretty popular in calculus. But what's the slope now?
It's going up.
Increasing?
Okay, so from -infinity to 0, with a parenthesis, not a bracket, okay, it's decreasing. And from 0 to infinity, we have a positive slope, so it's increasing. Okay. Questions, comments, thoughts, complaints, concerns, cares?
No. That was a lot of words.
Wait. Quick question.
Go ahead.
Why? Okay. Why, when they're when they're even numbers, the exponents, the curve, but when they're odd numbers, they do like a little swiggle. Why? Tell me why. See, those are all odd exponents.
There's no squiggle here.
Okay,
But it's straight.
yeah, it's not a
Okay.
Parabola.
Odd. Some of you know this better than others, but when you're odd, you can be single, and when you're single, you go your own way.
Okay,
Wow.
So we're either going down on the left and up on the right, or we're going up on the left and down on the right.
When you're odd.
But when you're paired,
You go the same
go
direction.
together.
Oh, that's like.
pairs go together,
Did you
either-
create that?
up, or pairs go together down, huh?
Did you just create that?
I've been saying that for years,
Oh.
That's smart.
okay? Pairs go together,
We've been telling kids they're odd for years.
oh yes, and some of them have known it even longer than I've told them. Right, Cassie?
That's on the recording.
Yes.
Rude.
But where do you draw the line between rude and honest? Sometimes it's the same. We'll just go with it. Okay,
I'm going.
Cry, Cassidy. Cry.
I'm just thinking of.
She's trying to think of a comeback.
No.
You're old. Come on.
16 more days.
That's on the recording.
16 more days.
I'll be 49.
That's not old. Just wait till
Grandma's
you're
My
older
60.
mom's older than that.
Okay, graphs of general polynomial functions. As with quadratic functions, the absolute value of A determines the width of the graph. Guys, there's nothing new here for us,
Okay.
okay? If A is greater than 1, what's going to happen to the graph?
It stretches vertically.
It's going to stretch vertically, right? So if this is the origin, if A is greater than 1, it's going to stretch it this way. Here's the origin. If A is less than -1, let's say A was -2, it's now stretching it this way because it's been reflected also. Okay? So it's a vertical stretch from the origin. Okay? If A is between 0 and 1, it's going to compress it. So if A was 1/2, it's going to compress it down this way. If A was -1/2, it's compressing it down this way. And that was recorded. Not necessary. Nothing new there. Here's a chart of a lot of the things we've already talked about.
Your board just always screws up.
I think what happens is after I type in the whole thing, I do a spell check, and if there's a word misspelled, I think the screen that had a misspelled word moves stuff around on me. I think that's what's happening.
I thought you didn't make mistakes.
I don't.
Uh-huh.
Yeah, it's the keyboard.
Oh, yeah?
Yeah, sometimes it misses a letter.
Mm-hmm.
So, a negative is a reflection across the x-axis. Plus k moves it up or down, k units. Minus h moves it left or right, h units. Moving on. We are going to graph f of x equals x to the fifth minus 2. Then we're going to determine the largest open intervals of the domain over which each function is increasing or decreasing. I will start this by graphing the parent function. And what is the parent function of the given function?
X,
To the
fifth.
fifth power. That is the parent function. I'm going to start by graphing x to the fifth power. Diego, you with me?
Yes, sir.
Okay, just checking. So let's graph this real quick. 0 to the fifth power.
0.
Man, you're
Oh, wait,
struggling.
were
on
you
that.
waiting for us?
Yeah.
I thought you were just like
I'm still
pausing.
waiting.
1 to the fifth power.
One.
1. 2 to the fifth power.
3.
32.
What the heck?
Okay. Did you see what just happened there? Man, it took off. Negative 1 to the fifth power.
Negative.
Negative 1.
1.
Negative 2
Blast off.
to the fifth power.
4.
Negative 32. Do you see how steep this is?
Yeah.
To get from this point to 2, to go that far, to go 1 unit to the right, I'm going to go up 31 squares
Nope.
to get to 32. Okay? So it is super, super, super steep here.
Gross.
Just like over here, to get to negative 32, it is
Wait, is this like-
super, super steep. And because this is to the fifth power, it's going to get close to the x-axis really fast and look kind of flat there. So it's coming up here, kind of looking flat, and then taking off there. That is approximately what the graph of x to the fifth looks like. So what happens when I graph f of x and have x to the fifth minus 2?
You have to move it all down.
Wait, that was.
That was just the parent function. I'm now going to graph f of x. I'll graph it in red.
Okay.
What's going to happen?
Goes to down.
Move it down 2 units. So there, there, and there. Coming up, flattening out, going up. And going really, really, really steep. And then coming down. Really, 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 really steep, like so. Okay? I have 2 questions to ask on this. Determine the largest open interval over which the function is increasing. When is that red function increasing?
0 to infinity. Oh wait, wrong one. Negative.
When is it
2.
increasing?
When is it increasing?
Negative infinity.
Increasing on the interval. Starting when?
Negative infinity.
Until when?
Infinity.
Oh.
And when is it decreasing?
Infinity.
It's not. Question mark?
Never decreasing. be kind of silly if you told me that a function's increasing all the time and then say, oh, but over here it's decreasing.
Wait, but how did it increase? You know?
I
Because
don't
it's
like,
going up. We read from left to right. We read from left to right.
What about it going down?
yeah, because that air's putting down.
Think about the x value. I'm way over here at negative infinity. Where am I gonna go as I move to the right? I'm going up,
Oh, so
I'm going up.
okay, so it's only going
okay? Remember, when you're talking about when a graph is increasing or decreasing, you're talking about the value of x.
So if it has like that squiggle in it, it's always increasing, no matter what?
Um,
Unless it's this way?
Well, we're gonna see graphs that might be like this. Is that graph ever decreasing?
Yeah.
Yes.
Is it always increasing?
No.
Okay, but it's down there forever and it's up over there forever, but it does some weird stuff in the middle, right?
Oh, Lanta. I don't know how you have the patience for that. I thought you had to scribble.
All right, let's look at one more. F of x equals x plus 1 to the 6th power. I will call g of x the parent function to that. And what would you say the parent function to that is?
X to the 6.
X to the 6th, perfect. Zero to the 6th power,
0,
1 to the 6th power,
1,
2 to the 6th power,
Okay.
32.
that's 5th power.
Oh,
Double it
33.
again. Double it again,
Oh, wait.
64.
64. Okay,
64.
so
Holy guacamole.
from here to here, it's going to increase 63 more spots. It's way off my screen. Negative 1 to the 6th power,
Negative 1. I mean, 1.
positive 1.
Whoops.
Negative 2 to the 6th power,
64.
64.
Oh, so that's a problem, right?
Okay, it's going to have that U shape to it. Okay, what's going to happen as this thing gets closer and closer to the x-axis?
It's gonna be decreasing.
It's
The bottom kind of flattens out, right?
yeah, it's gonna be
That's
less
what,
sweet.
that's
Okay.
part of it.
So it's like really steep. It's still really steep, but it's got to change directions. So it changes directions, and then it takes off again, and then it's almost straight up already.
Oh, should talk to you after this. I do. Thanks for noticing.
So what does that plus 1 do?
Make it
yeah.
go
Yeah,
one,
one to the
one.
left.
No, to the left.
Oh, yeah, because it's
Oh
in
yeah,
the.
to the left.
So I'm going to take every one of those points and move it
Gross.
1 to the left. So it's still kind of flat down here
Oh.
as it's approaching 0 and negative 2. And then it's almost straight up.
I wish I had a graph on my paper.
I do.
Because mine looks kind of crazy.
So let's talk about intervals on this real quick. When is this graph increasing?
From 0 to infinity.
And what kind of a mark will I put on the left side of the 0?
A bracket. No, question mark?
Parentheses.
Parentheses.
A parenthesis.
Because at 0, the slope is actually 0. Okay? The instant I pass 0, it starts to increase. And it's going to increase until
Infinity.
infinity. And it's decreasing.
Negative infinity to 0 with
Perfect.
parentheses.
Beautiful.
Oh my.
So does that mean it's constant at 0?
No.
But then doesn't
In order for a graph to be constant, it's gotta stay the same value for a length of time.
Is it increasing or decreasing at zero?
That's why there's parentheses there. It's neither increasing nor decreasing.
Wait, but
And it's not constant because it's only one exact point. Constant means it's gotta be the same over a period of time, okay?
it's neither, but.
It's like an instantaneous change. It instantly changes from decreasing to increasing.
We got 5 minutes plus. I'm going home.
What?
Adios.